Okay, so let's take a look at the next example. This time we have a parent function of y equals 2/5 to the x. All right, so our base is 2/5 this time instead of last time when we had a base of 2. All right, so we take and we build our parent function table. We've got -1, 0, and 1 for the x values. So those will always be the same. And when I plug those in, I get 5/2 because the negative exponent will flip it over, 1 and 2/5. All right, if I look at my transformations, we look up here in the exponent, that's going to tell us that we're going to shift right 4. So each of those x values is going to go up by 4. So we're at 3, 4, and 5. All right, now I look at the other two spots. I've got a vertical stretch and reflection with that -3, and then I've got a shift up of 2. All right, so when I look at that, I'm looking at times -3 plus 2. Now over here on the right, I did the work for that. So we have each of those numbers. So we get -11/2 for the first one. Then when we plug 1 in, we get -1. And when we plug 2/5 in, we get 4/5. All right, so we'll go ahead and plot those points. So we're at 3, -5.5, 3 and down 5.5. All right, then we've got 4 and -1. And last but not least, we've got 5 and 4/5. So at 5, we're at 4/5 up here. Now, we know the parent function on this one was decay. And that's because the base is less than 1. Base is between 0 and 1 decay. Base is greater than 1 grow. Right? So the parent exponential function looks kind of like this. Right? That -3 in front stretched it and flipped it over. So we're expecting something that kind of looks like this coming up from the bottom, right? So we expect to see that happening, but it's going to be shifted right and up as well, right? So that kind of gives me an idea what this graph looks like. We're up 2, so I know my horizontal asymptote is going to be at +2. And then we can kind of just take the shape of an exponential and connect the dots that we have from our work. Right, so we're going to get a graph that looks kind of like this. Now, the important thing to remember is this does keep going to the left. It just gets really big negative numbers. All right, so asymptote, y equals -2, or sorry, +2, y equals +2. Domain is -infinity to infinity. That'll always be true with exponentials. The range, this one comes up from -infinity and goes up to +2, but never touches it. Now, for a problem like this, I don't typically use the classification of growth or decay. If they ask that, I would reference the parent function. All right, so the parent function y equals 2/5 to the x. I would consider that a decay function. Now, this is a kind of a mean question to ask in this case because the reflection has it coming back up, but the parent function is what I would really be focusing on if I was asking growth or decay. Transformations, we've got a shift right 4. We've got a vertical flip, a vertical stretch, and that's by a factor of 3, and then a shift up 2. And that would give us our graph for that one.